So today we're going to focus on some other angle theorems involving circles. So the first one is if we have two chords, so you can see the two chords here, and they intersect, then the measure of each angle formed, so we're looking at these two which are the same because they're vertical, is half the sum of the two arcs that are intercepted. So I'm looking at these two angles. I see one arc that's intercepted and across from it another arc that's intercepted. So how this works is we'll start with the angle on the inside, which is x in this case, equals. I need to take half of the sum. I'm going to start with the sum. I'm going to add the two arcs together. So 32 plus 54. And then because I have to take half, I'll be dividing that by 2. So simplifying, 32 plus 54 is 86. That still needs to get divided by 2, which gives us 43 degrees. So that right there is 43. It's all it's asking for, but I'm going to fill in the other angles just so you know. Remember, these are vertical, so up here will also be 43. And then we have intersecting lines, and we know all lines form 180 degrees. So if I subtract the 43 from 180, each of these will be 137. Just so you know that you can find all four angles in there. Okay, example 2. Be careful. Notice where the x is this time. So if you look at the last one, like the x was directly across from its angle. Here, from its arc I mean, here the x is across from this arc. And that's not the arc we have. But we did just learn that we can find all four arcs and angles in here. So because I have these two arcs, I need to find this angle. I'll call it y. Then we can, at the end, go back and find x. So y equals, and we're going to add the two arcs and divide by 2. 19 plus 107 is 126. Divide that by 2, and we find that y is 63 degrees. So that's the angle here. Now they want x though. Remember, their relationship is that they add to 180. So to find x, we're just going to do 180, take away that 63, and we will get 117. So just make sure you're looking for the right angle. All right, example 3, a little trickier. This time, the thing we're looking for is not the angle, it's one of the arcs. Notice the angle is still perfectly opposite its arcs. So we're setting up the same equation, however, the variable is going to move in a different place. So in both of these, we've started with the angle at the intersection, the x or the y. But for here, we're going to be starting with that 115. The angle equals, we're going to add the two arcs together. So my one arc is x, my other arc is 105. We're still dividing by 2. So the x just moves to a different spot. Now to solve this, this is saying divide by 2. The opposite is to multiply by 2, both sides. So goodbye to these 2's. 115 times 2 is 230. Now all we have left is the numerator over here. One-step equation, opposite of adding is to subtract. So we get that x is 25 degrees. All right, you can pause it here if you'd like, there are 5 of those for you to try on your own, or you can wait till the end. I'm going to move on to the next theorem. Okay. The next theorem is going to hold true for 3 different cases. It's going to be if we have a tangent with a secant, a tangent with a tangent, or a secant with a secant. So any combination of tangents and secants, this theorem's going to work. So it's very similar to the one with the 2 chords. The only difference is that instead of adding the 2 intercepted arcs, we will be subtracting the 2 intercepting arcs, still taking half. So I'm going to highlight to show you. So how these formulas start is with an angle outside the circle. So this angle 1 here, I'm going to highlight my secant and my tangent, and I see 2 chords that arcs that it cuts off. It cuts off this small arc, AC, and it cuts off this larger arc, BC. Notice AB is not between the orange lines. So those are the 2 arcs we're using to subtract. Always subtract the larger one from the smaller one from the larger one. So we'll start the larger one. So the measure of angle 1 is arc BC, take away arc AC, and that will be divided by 2. That's how that works. So the next one, same idea. This time we just have 2 tangents. I'll highlight them in orange. I'm going to highlight the 2 arcs I see. Here's my smaller arc. Here's my larger arc. What's interesting about the 2 tangents is notice the 2 arcs actually make the whole circle. That's going to be important later. The bigger arc is arc PQR. Take away the smaller arc, which is PR, and that will be divided by 2. All right, last case is if we have 2 secants. Again, I'm just looking for the arcs that's in between the orange lines. So this little one, WZ, and this larger one, XY. Larger one goes first, so XY, take away WZ, and that will be divided by 2. So all 3 of these you'll see, we're looking for the angle outside here. Okay, subtract and divide by 2. All right, let's do some with actual numbers in them. All right, so our equation's always going to start with our angle outside. Our angle outside in this one is x. Looking at the 2 intercepted arcs, I have 70 and 164. 164 is larger. And then we will simplify. So 164 minus 70 is 94. Divided by 2. And we get 47 degrees. All right, let's take a look at the next one. We start with the angle outside, so x. The larger arc here is 240 minus. Now, it feels like they didn't give us that other arc, but there's a way to find it. Remember, we were saying before that for 2 tangents, you actually get the whole circle with the 2 arcs. So to find the other arc, I just have to subtract it from 360. So I now know that this arc is 120. I can't do that in the last one because notice like there's an arc that hasn't been used, okay? But I can always do it for 2 tangents. So 240 minus 120 divided by 2. So that's 120 divided by 2, and we get 60 degrees. All right, last one. We start with the angle outside. This time notice in the last two the angle outside has been x. Now the angle outside is 50, so we still have to start with that. 50 equals the larger intercepted arc minus the smaller one, which is our variable this time, still getting divided by 2. Now the last time we had to do this, we had to multiply both sides by 2. So we get 100 equals 170 minus x. Subtract 170 from both sides. So I have negative 70 equals negative x. There's really a negative 1 here, so I'll divide by negative 1. And I get that x is 70. Okay, so again, the variable may move around. You also need to pay attention to making sure it's the arc between the two intercepted between the two lines. So careful on that when you go to do the practice problems. So you can pause here and work on those. I'm gonna move on to the last example. It's not a new theorem, it's just a tougher example that I want to show you how to do. So on to example 4 here. So notice it's still the angle outside, right? I have two intercepted arcs. So the angle outside equals, so it's just more complicated because I have these like larger algebraic expressions here. The larger arc minus the smaller arc, still getting divided by 2. All right, it's a couple things you can do to tackle this. Personally, I kind of just want to get rid of that 2. I want to just multiply by 2 right away and get rid of that nasty fraction. So I now have 60 equals 5x plus 10 minus 3x plus 4. All right, next line. We have two binomials here getting subtracted. The first guy is going to stay the same. But the second one, there's this negative 1 that's got to get distributed into both terms. So that turns into negative 3x, and that 4 turns into negative 4. So be careful on that. We're going to combine like terms now. 5x minus 3x is 2x. 10 minus 4 is positive 6. Move the 6 over. I get 2x equals 54. And when I divide both sides by 2, I get that x is 27. Okay. So there's a few of those for you to try on your own also. And there's an answer key for you to check your answers over.